I hope it will work. Does it work? Yes? The mic. Okay. So, we start. Dear Professor Messer Yaron, the Vice President for Research and Development of the Tel Aviv University, dear Professors Waterman Storer and Yulicha, the laureates of the Sackler Prize for Biophysics, dear colleagues and guests. On behalf of the Prize Committee and its local members, Professor Klafter, Professor Andelman, I am happy to welcome you to the ceremony of the Raymond and Beverly Sackler International Prize in Biophysics for the year 2007. This is the second year that the Tel Aviv University is awarding this prize. 2 years ago, the family of the Sackler family, Raymond and Beverly Sackler, established this prize, and their wish was to support the development of the interdisciplinary field, namely biophysics, which lies at the crossroads of biology and physics, first of all, but also of medical sciences, chemistry, and engineering. Since the field of biophysics is so broad, every year a prize is formulated for a somehow narrow area of biophysics, and the area of this year's prize was chosen to be biophysics of molecular and cell dynamics. I'm going to explain a little bit what was the motivation for this formulation. A live cell is essentially non-equilibrium system. In the best case, it can be seen as a steady-state system. A live cell, all compartments and components of a live cell undergo a persistent turnover and transformations. And this is possible only in conjunction with movement in space and motion in space. Indeed, if you look what happens within a cell, you will see, and we will hear about it from the talks of our laureates, definitely. You will see that there is constant motion at all levels, beginning from the scale of single molecules through the scale of supramolecular assemblies and up to whole intracellular compartments. And this is not all. Also, the whole cells. The cell as a body moves in certain, has to move in certain biological processes. So this motion, which must be related to development of forces, is so amazing that it attracted the attention of both biologists and physicists. And during the last 2 decades, or maybe 1.5 decades, a breakthrough has been reached in understanding the cell motions, which is first of all due to development of new techniques, basically microscopy and spectroscopy techniques. And we will hear about one of the most important techniques in this field. And but also a very important role was played by involvement of soft metaphysicists who tried and are still trying to understand the physical mechanisms behind the intracellular and cellular motion. This amazing field motivated a formulation of biophysics of molecular and cell dynamics as a topic of the Sackler Prize for Biophysics in this year. For the year 2000, the prize committee has decided to award the prize to 2 distinguished internationally recognized scientists. One is a quantitative biologist whose results give a solid and absolutely necessary background for starting understanding the physical mechanisms of biological processes. I mean, the numbers is very important, as we all know, to start modeling and to verify models. And the numbers don't come from biology often, and the scientist chosen as a laureate, as a recipient of the prize in this year, does provide the numbers which are very important for biophysics. And the second recipient is a top theoretical physicist who took a risk many years ago to change his attention from the simplified physical systems to very complex processes running in live cells in all their complexity, to address these processes and to be successful on this way. Exactly the combination of these two fields, a hardcore biology and hardcore physics, and development of a common language between these two disciplines, which is not trivial, as all of us know, is, in our view, the future of biophysics. And this is what guarantees success of biophysics. I call upon Professor Mr. Yaron for opening remarks.
Thank you. Do we need it for recording? Because you can hear me. We are all teachers. We are used to it. Thank you. Thank you, Professor Koslov, Professor Klafter, and most of all, our both distinguished laureatee, Professor Waterman-Storer and Professor Julicher. That's the way you pronounce it? Thank you. I'm very happy to say a few words on behalf of the administration of Tel Aviv University. We are in the middle of the Board of Governors, and we are also in the middle of student strike, if you know. So I'm not sure if this is the reason to have you all here, but I most welcome such a lovely full hall with faculty members, colleagues, students, and more. The topics that we are awarding today, biophysics, is known to be, and we just heard a few words about it, to be one of the future topics in science. And it has many potential benefit to science, to application, to humanities, etc. But I'm not sure if you know, but in Tel Aviv University it was also identified as one of the future strategic direction in which Tel Aviv University is going to develop. We went through an exercise which we called New Horizon, in which, under the financial crisis that we have been to, we tried to identify few topics to be focused on the future of the scientific and academic development of Tel Aviv University. Altogether, 4 topics have been chosen, and one of them is biophysics. So from my point of view, from the university point of view, having people like you two coming here today, and the people that award this award last year, and the future will be maybe the core for our international relationship in this important topic. So I want to welcome you, and I also want to say that I'm very happy looking at the history and the CV of our 2 honorable laureates, and I'm very happy about 2 things. One is, you know, we attend these ceremonies quite often, and the typical person to sit here would have been a male at the age of between 60 and 70, and it's very refreshing to see our 2 guests here. One is a woman and the other one is a man, but not yet 50, I believe. So we have a long future of collaboration with them. I also see here in the audience the same diversity in terms of gender and ages, and I think this is one of the things that we have in science, we like to see in science, is people from different backgrounds, from different nationality, from different topics. Actually, here we have, as I can see, people from physics, chemistry, biology, medical school, Daphna, and others working together. Diversity, gender, age, research topic, and science, especially biophysics, put us all together. So I hope you enjoy the 2 talks, which unfortunately I need to miss as I said, this is in the middle of the Board of Governors and there are other obligations. And thank you all for coming here. Enjoy.
So now we are coming to introduction of the laureates. First I am going to introduce Claire Waterman-Storer. It's my great pleasure and honor to introduce Professor Claire Waterman-Storer, the recipient of the Raymond and Beverly Sackler International Prize for Biophysics in Biophysics for 2007. Claire got her master's degree from the University of Massachusetts in exercise sciences, which is physiology as far as I understand. But the topic of her thesis was already the cytoskeleton of skeletal muscles. Is it affected by exercise? So this indicates already the main direction, because cytoskeleton is the intracellular machinery producing forces within cells, moving everything within cells, and moving the cell itself. So her PhD is from UPenn, from the University of Pennsylvania in 1995, and the topic of her PhD thesis is already directly related to the topic of the prize, namely the thesis was devoted to investigation of movement of intracellular organelles mediated by microtubules. Microtubules is one of the parts of cytoskeleton. Microtubules is more or less a railway, intracellular railway, enabling movement of molecules and compartments within cells. After a postdoctoral period at the University of North Carolina, Claire joined the faculty of the Scripps Institute, of the Scripps Research Institute in California, the Department of Cell Biology. And now, in these days, actually, Claire is moving from the east coast of the United States to from the west coast to the east coast in order to join as a lab chief the National Institutes of Health, NIH and Bethesda. In 2 weeks, as far as I understand, she will be already there. Even at the stage of announcing the prize, as we came to the decision to award the prize to Claire, and we wanted to catch her by phone and to tell her this good news. It turned out that she is not in California, and I got her mobile telephone number from one of her lab members, probably postdoc student, and I called, and Claire was somewhere on the way in Washington, D.C. on the street, and this was just in the middle of arrangements of this move from the west coast to the east coast. So Claire Waterman-Storer is the founder of an essential and very important experimental technique, the method of fluorescent speckle microscopy, which proved to be one of crucial methods to study the intracellular motion, and more exactly the motion of large proteinic assemblies, such as actin filaments, microtubules, and recently proteins within so-called cell legs, cell adhesion complexes. While the research of Claire can be classified as a mainstream biology, still it has a very distinct feature, which was especially pronounced in her latest works. Namely, Claire provides, as I said already, numbers about velocities within the cells, numbers about distribution of moving components within the cells, and these numbers must and will serve as a solid background for physical modeling. The latest results of Claire published in Cell and Science magazines during the last years were obtained in collaboration with the computational biophysicist Gaudens Danuser, and this says that Claire has a clear tendency and understanding of the quantitative and physical side of the biological events she is investigating, and this is very important from the point of view of biophysics. The prize is awarded to Professor Claire Waterman-Storer for development of the method of fluorescent spectroscopy and its successful applications to quantitative studies of dynamics of cytoskeleton and cell adhesions. I call upon the Vice President of the, for Research of Tel Aviv University, Professor Messer Yaron, to award the prize to Professor Claire Waterman-Storer. I call upon Professor Cluster to introduce the second recipient, Frank Jurich.
It is also my pleasure at this time to introduce Professor Frank Jurich, the co-recipient of the 2007 Sackler Prize. A few milestones in Frank's career. Frank completed his undergraduate study in 1986 in the University of Stuttgart. His diploma study at Aviv in 1990, and his PhD study at the University of Cologne, combined with doing research at the Research Center, all in Germany. Between the years 1994 and 2001, he was a postdoctoral fellow at the Samuel Prager University. And then he joined the research staff, joined the research staff member at the Curie Institute in Paris. Since 2002, Frank is a director at the Max Planck Institute in Dresden. This is the Max Planck Institute for Physics of Complex Systems, and this is combined with a professorship at the Technical University at Dresden. Frank has been a driving force in making the Institute in Dresden a world center in biophysics. Now, Frank Jurich made substantial contributions to a number of challenging problems in biophysics. He has been one of the world leaders in theoretical biophysics and successfully applied ideas from various areas of physics in order to get a better insight and understanding of biological systems. His exceptional contributions include membrane body and conformal diffusion, collective effects of motor molecules, cilia and flagella, beating motion and oscillations. I hope you'll explain some of these subtleties here. The mechanism of cell mobility and cell division, and more recently, the physics of hearing. In all these, his contributions were pioneering and extensive. Now, as for the citation, the prize is awarded to Professor Frank Jurich for his pioneering discoveries and contribution to the physics of non-equilibrium biocellular systems, such as molecular motors, active membranes, filaments, and cytoskeleton. And I call upon Professor Yaron to award the prize to Professor Jurich.
Okay, so let's which is more important. Okay, congratulations.
want to thank the organizers of the Sackler Award for this opportunity and this great honor. Dr. Klafter and Dr. Kozlov for the opportunity to come to Israel. I have family history here. My mother and father eloped to a kibbutz in the 60s and lived here for 5 years. And I've had a chance to visit, so this was very exciting to be able to both receive this award and particularly receive this award in a place that's important to my family. I also want to thank specifically my collaborators who have contributed to my ability to, I see biology, I see that it can, how I want to describe it. My abilities as a mathematician and a physicist don't, fall short of my ability to describe what I'm seeing, and so it's really through extensive collaboration that we're able to get a physical picture of what I can see myself. And that particularly, I thank Gavin Stanuser, my colleague who moved from the ETH in Switzerland to across the hall from me at Scripps, and we've been a great team where we train graduate students together to get a quantitative and physical training as well as biological experimentation training. And we're hoping that by doing this, we're contributing to the future of understanding biology. Thank you also to Tel Aviv University for recognizing the importance of this direction in biology. So thank you very much.
So I'm calling Professor Frank Ulicher to say a few words.
So I'm very honored to be here at this occasion for this award. It's my second visit to Israel. It's a great pleasure to be back here with so many friends. In my research over the last 10 years, I've been mainly interested to understand how molecules cooperate together in groups and to identify mechanisms that can be relevant for what goes on in cells. This research was only possible because of many collaborators and co-workers whom I want to thank especially here. There are also a number of colleagues who were very important during my career. I'd like to mention in particular Jacques Pro, with whom we started to enter this field using statistical physics to look at biomolecules and their cooperative behaviors. This has been a very joyful, fruitful, stimulating interaction for many years, and there has also been a good friendship. I'd also like to mention Pascal Martin, with whom we've been working on the chemosensory cells, the air cells that in our ears detect sounds, which also involves a long-standing collaboration. Carsten Kruse was an important colleague who started together with me in Dresden the new department that was built up on biology and physics. And in Dresden we now have a very flourishing environment, scientific environment in many areas. And in particular biophysics has flourished because of a strong collaboration between physics institutes and the cell biology and genetics institutes. We have close collaboration with Joe Howard and Tony Heimann and many other colleagues there. And it's a great pleasure to do science there. Finally, I'd like to thank the organizer of this prize for the invitation here to Tel Aviv, the hospitality. Thank you very much.
So I would like to thank once again everybody who came here. The formal ceremony is closed. In half an hour, a little bit less, at 3 o'clock, we'll start the scientific colloquium. The first lecture will be by Claire, and the second lecture will be by Frank. All are probably invited to stay for the lecture. Thank you very much.